Okay, so this is the 2008 AP Chemistry Free Response question number 6. So for part A, it says structures of the pyridine molecule and the benzene molecule are shown below. Pyridine is soluble in water, whereas benzene is not soluble in water. Account for the difference in solubility. You must discuss both of the substances in your answer. So for pyridine, we can see that since nitrogen has a lone pair, that the structure will be polar. This means that it can form hydrogen bonds with water, and since water is also polar, like dissolves like, so it'll be able to dissolve in water. And then it's soluble due to its strong hydrogen bonds. And then when we look at benzene, we see that we have our carbon chain and that there's no lone pairs, so we can tell that it's non-polar. And since we know that water is polar, it won't be able to form hydrogen bonds with water, so it will not be able to dissolve in water.
For B, it says structures of the dimethyl ether molecule and the ether molecule are shown below. The normal boiling point of dimethyl ether is 250 Kelvin, whereas the normal boiling point of ethanol is 351 Kelvin. Count for the differences in boiling points, and you have to discuss both of the substances in your answer. So if you look at dimethyl ether, you see that it has London dispersion and weak dipole-dipole because of the lone pairs, whereas ethanol has London dispersion, dipole-dipole because of the lone pairs, and also hydrogen bonds because there's a hydrogen connected to an oxygen, which forms a hydrogen bond. And what you have to say in your answer is that the energy to overcome the intermolecular forces in dimethyl ether is less than the energy to overcome the strong hydrogen bonds in ethanol, so the boiling point is higher.
Okay, for part C, it says that SO2 melts at 201 Kelvin, whereas SiO2 melts at 1883 Kelvin. Account for the differences in melting points. You must discuss both of the substances in your answer. Okay, so I had to put the answer down here below because there's not enough space, and on the AP test you won't necessarily be writing your answers on the page with the problems. You'll get line sheets of paper to use for that. So we know that SO2 has dipole, dipole, and London forces, and we know those are relatively weak, so we can overcome them with a lower temperature. So that accounts for the lower melting point of SO2. And then we know that SiO2 is one of those special molecules that has a network of covalent bonds, which requires a much stronger or much higher temperature in order to break those intermolecular forces, because they're much stronger than traditional or typical intermolecular forces. So we know that SiO2 has a higher melting point than SO2.
Okay, so for D, they tell us that the normal boiling point of Cl2 is 238 Kelvin, is higher than the normal boiling point of HCl at 188 Kelvin. You need to account for the differences in normal boiling points based on the types of intermolecular forces in the substances. You must discuss both of the substances in your answer for full credit. So first, Cl2 has London dispersion. HCl has London dispersion and dipole-dipole interactions. Cl2 has a higher boiling point, so its London forces are greater than the London and dipole-dipole forces present in HCl. Cl2 has more electrons than HCl, so its London interaction is stronger because the strength of London forces among molecules is proportional to the total number of electrons in each molecule.